Hey, if you'd like to support the production of more Moof University video tutorials, then please visit the Support Moof section on moofuniversity.com. Thank you and enjoy.
In the last video we saw that we made IPP and DMAPP, and we're going to have these guys as our isoprene units that we're going to link together to eventually make squalene. Before I actually get into the reactions though, I do want to mention that whenever we're talking about one of these molecules, we're going to have a head end and a tail end. So we'll call the head end the end that has the pyrophosphate portion. So this here would be the head end, and this would be the tail end of DMAPP, and then IPP, this would be the tail end, and this would be the head end. Okay, and that's going to be the same for any molecules that we'll see here. Okay, so the first thing that we're going to do is we're going to link DMAPP and IPP, and what's going to happen is carbon number 5 of DMAPP is going to link to carbon number 1 of the IPP, and we're going to lose this pyrophosphate group here. Okay, so we're going to lose that blue one there as a pyrophosphate, and this is going to be catalyzed by prenyl transferase. Prenyl, of course, referring to the isoprene units that we're talking about. So now we have this molecule here, which is geranyl pyrophosphate, which is 10 carbons long. Each of these 5 carbon units was linked to make this. So this condensation reaction here, we connected the head unit to the tail unit. So this is a head to tail condensation. Okay. This next one, we're going to take geranyl phosphate, or pyrophosphate, excuse me, and we're going to link it to the next an IPP. Okay, and we're going to get farnesyl pyrophosphate, which is going to be 15 carbons long, and we're going to have this end being the head end and this one being the tail end here. This is the tail end of IPP and the head end where the phosphates are, and we're going to link carbon 5 of this red portion to carbon 1 of the IPP here, of the brown IPP. So that bond is made there. So again, we're linking the head to the tail. So this is a head to tail condensation as well. Also catalyzed by prenyl transferase. Okay. Then we have farnesyl pyrophosphate, which is a 15 carbon molecule. And what we're going to do now is we're going to take that and we're going to use that and another farnesyl pyrophosphate to make squalene. Okay. And we're going to link those. But before I actually get into that, I want to ask, where did this other farnesyl pyrophosphate come from? Well, it came from these same exact steps. We're just going to do all those things again. So if I erase here to reveal what's going on over here, I basically have the same exact reactions shown here that give this other FPP. And I've drawn this other FPP to sort of mirror the other one here. Right? If we put a mirror in between them, just like right here, right? They're just mirror images of each other, right? Reflections and whatnot. So we're going to take these two 15 carbon units and link them together to make squalene down here. And so we're basically going to link this fifth carbon here to this fifth carbon here of these two brown portions, and we're going to lose both of these pyrophosphate groups. We're going to lose both of those. And we're going to link those two carbons there to give us squalene. So in this case, we've got the head end here and the tail end here, the head end here and the tail end here. So here we have a head-to-head condensation. Head-to-head condensation. And this is going to give us squalene. Okay, and this requires an NADPH, reductive biosynthesis. Makes sense for building cholesterol long term here, so it makes sense to have a reductive or a reducing power in the form of NADPH. And this is catalyzed by squalene synthase. Okay. And now we have squalene, this 30 carbon molecule that is the precursor to cholesterol. All we need to have now is stage 4, which is the cyclization. So I hope this video was helpful. See you in the next one.
Thanks for watching, and be sure to like, comment, subscribe, and share the video with anyone who you think might find it helpful. Thanks, and happy studying.